Hello and welcome to part 2. This time we will look at some basic theory about version control systems and Git. There are other version control systems than Git. I think I used Subversion in my university times, but as I mentioned in the previous video, Git is widely used, so that's our focus point. But there is some general ideas about version control systems. So what is it? What is Git? What can we do with Git? And what is GitHub or similar? I think there's something called Git Kraken, which is also used. And what are the basic commands that we can work with to upload and download code and work as a team on our code. So the first point, version control system, is used to manage and track changes in your software code over time. So I guess we can consider it a bit like a quick load system. You can quick save your code, so a snapshot of what your code looks like at a certain point in time is saved, and then as you move forward, maybe you code yourself into a corner and you make a mistake and you would like to go back to a previous save and reload that, and that's essentially what you can do. So you can get this history of what your code looked at these snapshots. So often I see my students, they will just try to control set if they do something wrong or delete something or want to go back, they control set and to undo the changes all the way back, and that's not always enough. Sometimes you have closed that window or you restarted your IDE or whatever. I guess the undo stack is limited to how many undos you can do, so obviously this is not a reliable method to go back in history. It also makes it possible to share code and collaborate with other team members. So there is a cloud storage where you can upload your code to, and other people can download that code, and when they make changes they upload it to the cloud storage, and you can download it and get their part of the code. Because sometimes I have seen students just send zip files around and try to copy paste code inside, or they share stuff on Facebook or OneDrive, and that's just a lot of hassle to put different parts of the code together. You have one method and some other person has a method, and you're going to put that into the same class, and you need to remember the field variables and the change to the constructor arguments, and it's just, yeah, a lot of work. Okay, let's take an example. So each of these bubbles, this is how we usually or I will in this video, inspired by a lot of other diagrams. This here represents a snapshot of your code. So initially we have an empty project, but no actual code in that. And then we write some code. Maybe I have a simple main method, and I want to start up my console UI, and this will then be version 1 of my code, and I can save that code, which is called commit. Sort of the same thing. So commit is the git command, and now I have a new snapshot of my code that is looking like this. I can go back in history. I can view this part here if I want to, right? So this is version 1, and I can go forward again and view my version 0 and version 1. So I have quick saved my code, we can call that. I've committed my code so that it is Git has a status of what it's looked like at this point. And then I keep working, and I have a version 2 of my code. Now I also want to run the UI. Tiny bit of difference, but I can now quick save again. I commit this code, and that creates a new version of it. Right, and if I made a mistake, maybe I didn't want to run it, I can go back and see what did it look like before, so I can see in the history this is what I had before, right? And then maybe my oh, there we go. Maybe my console UI needs to save some data, so I want to add some class to manage that. And that means I need a version 3, and I create my data access class, and I'm supposed to store it in JSON. That was the idea. And this is now an updated version of my code, and I can commit that, and I have a new version of it. And so I can go back and forth if I want to and see the changes made over time. So that's very convenient. Now, another thing that we can do is this branching thing that I mentioned in the previous video, which we will look at more later on. But essentially means that multiple people can work on different parts of the code or different version of the code. So I may have my initial version, and I've committed a version 1, and then someone wants to implement a new feature, and they say, okay, instead of working on the same code as someone else, I will take this version here, and then I will start a new version here. So this is a different branch, it's called. And this team member can work on that branch and create commits, and another team member can continue working on the original branch and do their commits. So they are working in parallel on different versions of the code, and at some point the person up here has made enough code and they want to put that together. So this is where, as I mentioned, the students would sometimes, zip this and say, okay, whatever changes I've made, you need to sort of copy paste that into your version here, and they always forget something or mess it up, and that just takes forever. But with Git we can say, take this and put into that, and that's called a merge. So all the changes here are put into what we have here, merging together into a new version here, and this is super powerful, and we will get back to how to use this. So that's the merge part. Okay, so what is Git? Popular version control system. You have various commands and tools that I have mentioned, so you can work with your code. Git is tracking all these changes of your code, and it makes it easier to work together in a team. So let's assume that we have a team working super hard, and in this case they are all working on the same version of the code. So this guy here, person A, has made some changes, and he wants to commit that, make that quick save. So the changes goes into a local repository that is located on his own computer, and he has different versions of it. Each commit makes a new version, and at some point he wants to share what he has made with the other team members. So it is pushed to the repository in GitHub. This is where your code is hosted or saved, so that other team members can get access to it. And another team member, this girl with a name that starts with B, Beatrice, I guess, also works, and she commits stuff, and she has different versions, and she wants to put that up to GitHub. So there are some more steps involved in putting the code together, but it's just a bit simplified here. So she's also putting it up here, and the last person here can then download the code, so he gets whatever has been changed, and he puts that together with his own code, and then he can make a checkout. So now he has updated his local version of the code with everything that person A and B did. There's also something called pull, which sort of skips this step, is my understanding. So it's just uploading and downloading code to this shared repository, essentially, to put it short. So I found this activity diagram or sequence diagram that I think was a very good illustration of what we can do with the various commands. So you have your workspace. This is your what you actually see in your IDE, for example IntelliJ. So this is the code that you're looking at, or writer. You have a staging area, which is keeping track of everything that has been changed, and you have a local repository, which is your local save game history. This is where you commit your code to. So these are all locally on your computer, and Git is managing these for you. And then we have GitHub, which is in the cloud somewhere on a remote server, and you can do different things. You have different commands to put your code or download your code, upload and download it, and manage it with GitHub. So for example, if you add a new file, you want to add it to Git so that Git is tracking this file, handling the changes, and that means we add it to the staging area. We can then commit the file so that it is stored, this version of the file is stored in the local repository, so that's our save. Whenever a file is modified, we can commit that. We commit the changes to the local repository, so we have a version history. At some point we want to share the code with other people, so we need to put it to the cloud here, and that means we push it. So pushing takes whatever we have in our local repository and we push it up to the cloud storage on GitHub, our remote repository. Now IntelliJ Writer also has a combination of this, so commit and push. I guess it's just doing one after the other and not a separate command. So, but this is what you can do. So this is how you save your code and upload it to the GitHub. You commit code, or you commit changes, and you push it to the remote repository. And sometimes you also want to download changes because other team members have made changes that you want to put into your code. So that's the next step here, and you can well, first maybe you want to go back in your history. You have made some changes and you think that was not a good idea, so you want to sort of undo, reload a previous save. And you can do that by a reset or a revert command. That means taking a previous version and updating your workspace to match that. Now, as a team, there may be other people working on it. Otherwise, it's a very solo team. So they also have a local repository and they can push stuff to GitHub. And maybe you want to download that change in code so that you can work on it. Maybe they have made an interface or a utility class with methods that you need, and you want to update your local version to get that functionality. And if you make a fetch command, it goes into your local repository. And if you then make a checkout command, you can put it into your workspace. Now the checkout is also used to swap between branches. So it has multiple things you can do with it. Similar to the commit and push, I guess this one here, there's also a pull, which takes from your remote repository and merges into your own workspace. So I guess it's a fetch and checkout in one, as I understand it. And then finally there's a clone, which takes a remote repository and puts into a new folder. So I've tried to illustrate that. It goes into a new local repository. So this is when you want to start a new project, for example for your SEP project, I guess. Then you can have one member create a repository and upload the initial setup of the project, and then the other people in the group will clone that to a local repository and start working on it. So these are the most used command, is my impression. So that's at least what we cover here. And I want to put it in a different perspective with the branches, or local commits. So you have your remote repository, and there's some version of the code up here, and you have your local repository. So that's you working on the code. And when you want to work on this project here, first you make a checkout to get a version of it on your own computer, and you can then make changes and make commits, which is just stored on your local repository. And someone else also wants to work on it, and maybe they want to work on a different branch, because then they don't interfere with your code, your changes here. So you can have multiple branches, multiple parallel versions of the code, and someone wants to work on this branch, so they download it to they check out to the local repository. So the strong colors represents a branch, and the weaker, paler colors of the same, blue, pale blue, that's working on the same branch here, the same version, and pale pink is working on this version here. So this person also makes a new commit to save the changes, and some other team member also wants to collaborate on this branch. Maybe this represents a feature of adding a new product, and this guy here is working on a login feature. So multiple features often is done in separate branches. So someone else makes a checkout to a local repository, so we have two people here working on the same branch, and they have different versions of the same code. Gets a bit confusing, perhaps. Okay, so this person here has made some changes, and they want to push that to the remote repository. They want to upload or update the common truth. Alright, they push it. So now the remote repository has a new version, which is represented by this. So we have a timeline going towards the right, and multiple people here on the x-axis. So these people also work on their feature, which I already forgot was about, adding a product perhaps. And this person here wants to upload their changes, so they push it to the remote repository. We have a new version here, and they keep working. And then maybe this change here was something that this person here needed, so they will make a pull and update their local version of the code with whatever they have made here, so they can continue working. And this person here is continuing working and making new commits, new checkpoints, and they upload again. They make a push, so the remote repository is updated with a new version. And the blue person down here is continuing working and also uploading. So we have these two branches in parallel on GitHub, and this person here is continue working and uploading. And finally, whatever this feature was about, it is finished, and they want to put that together with the other feature, so we can put that together. There are some minor steps involved also, which are not shown here, but we'll get into detail with that. But this is the overall idea of things. So each bubble here represents a unique state or version of the code. I have the branches here, so whenever you upload something, it's not interfering with this guy down here, with the other branch, so you can work separately. And then when you're done with the entire feature, you can put it together like this. And Git is very good at managing this for you, all these different branches of the code, all these different versions. And there's my timeline. So that's an overview of Git. That became a slightly longer video than expected, but I hope this sort of gives you an overview of how you can work with Git and version control. So if I haven't lost your interest, maybe I will see you in the next part.